Okay, welcome to the fourth and final major unit of this class. It's all about network security. So before we do that, really quickly, last time we talked about SQL injection, and the idea was to feed in untrusted input into some query that is then parsed as SQL. This allows the attacker's input to also be parsed as SQL and allows the attacker to run their own queries, delete tables, add their own entries to tables, and otherwise mess with databases on web servers. And in general, we also said that command injection happens when you pass in untrusted input into any language. It could be C, it could be JavaScript or SQL, and they all somewhat fall into the same category of attacks. And the defense is usually to use safe API calls. For example, with SQL injection, prepared statements was a good defense. Then we talked briefly about CAPTCHAs. These are challenges that are easy for humans but hard for computers. But nowadays, the difference between a human and a computer is getting harder to detect. And in particular, machine learning has started to make the difference a bit less clear. And we talked about some issues, for example, accessibility issues when CAPTCHAs get harder, ambiguity, where we don't even know the solution as the person making the CAPTCHA, and also the fact that if someone wants to break a CAPTCHA, they can just pay humans to solve it. So that's what we talked about last time. Now today is all about networking. So just like in the first three units, memory, safety, cryptography, and web, we'll spend the first day just doing a very quick speed run of what the internet looks like. And then starting next time, we'll actually go into specific attacks. So today is all about trying to figure out what the internet is, how it works, and coming up with a somewhat simplified model of how it works. OK, we will start with the same question we always ask. What is the internet? So a network, that's a bunch of machines that are connected to each other, that can talk to each other, and they have to agree on some sort of protocol, which is something we'll talk about. And the internet is simply all of the computers in the world connected in a network. So you could connect everyone in this room, but the internet chooses to connect everybody in the world. And once you have the internet, you can send and receive different types of data over the internet. So for example, when we saw the web, that was just one of many different ways that the internet can be used. So you could use the internet by opening the web browser and sending HTTP requests and responses to load web pages, to load JavaScript. That's one way to use the internet. But it is not the only way to use the internet. In addition to the web, you could also use the internet for SSH, which is how you remotely log into a terminal. There's no browser there. That's just you logging into a terminal on some other machine. Or you could use the internet to play some online game. Again, there might not be a browser, but that's another way that you can use the internet. So even though web is probably the most common way people use the internet, you can use it to send and exchange any data that you want. It doesn't have to just be HTTP web pages. So that's what the internet is. It's how the computers are connected and not necessarily what you're doing with that connection. Protocols. These are really important, and basically the entire networking unit is just showing you like a dozen protocols and talking about how we might break each one. So when we design a network where a lot of computers are connected and want to talk to each other, it's very important that all of the computers on the network follow some agreed upon rules for how they talk to each other. So computers, they can't just speak English and say, well, give me this file. Instead, they have to somehow agree on specific rules for how they send and receive data. In particular, if you want to build a protocol, you have to specify two things. You have to specify syntax. And what that means is when a computer issues a sequence of zeros and ones, what does that mean? What does the first zero mean? And then if you see another one, what does that mean? So somehow we have to write down the rules for what the zeros and ones mean. Maybe a 0 means I got your message, and a 1 means I didn't get it, or something like that. So you have to specify what the ones and zeros represent, the format of the messages. And then the second thing you have to specify is the semantics of your protocol, which says when you do receive those zeros and ones, and you decode them to figure out what they mean, What do you do in response? If someone sends you a 1, what are you supposed to do? Are you supposed to do nothing? Are you supposed to send something else? And what if they send you a 0? So you have to specify what the bits represent, and then you have to specify what each person is supposed to do in response to each of those sequences of 1s and 0s. That's how you specify a protocol. It helps all the computers reach an agreed set of rules for how they talk to each other. Now, turns out protocols appear in other places too. So for example, when you and I are talking to each other, we have a protocol too. So it's not like any of us can talk anytime we want if we're sitting in a lecture. Instead, if any of you have a question, your protocol might look something like this. You're going to raise your hand. That's the universally agreed upon symbol for I have a question. Now, we could have agreed on something else. Maybe in some other world, somehow you raise your leg or something, and that's asking a question. But we agree that raising your hand is the syntax for how to ask a question. And then when you raise your hand, what do? Do you start talking right away? That's not what the semantics say. The semantics say if you raise your hand, you have to wait. And then when someone calls on you, that's your turn to talk. And then there's maybe additional rules. For example, if you raise your hand and nobody sees you, maybe you have to wave your hand, or you have to excuse me, and then hope that someone recognizes you. So these are sets of rules that we have agreed upon so that we're able to effectively communicate with each other, and we're not simply interrupting each other with words all of the time. So we have to build something like this, but for computers to effectively communicate with each other.